Math 7, what up? Lesson 6-8 on solving inequalities. What's so great about this front page is that it's just like solving equations, but only with a little inequality symbol. And then also we're going to include that graphing that we just did the other day. The back side, though, is word problems, and it will take a little bit longer. So on examples 1 through 4, I am going to go very quickly. Remember, you can pause, you can rewind, but make sure that you understand how to solve two-step inequalities. So this first example, again, we treat this kind of like an equation, only now we have a different symbol in there. I know that I'm going to look on the side with the variable, so 7, and 7 is positive. So since 7 is positive, we're going to do the opposite of that. Subtract 7 both sides. I now have negative 22 less than or equal to 2r. Then to get r by itself, I divide both sides by the number 2. Now I get negative 11 is less than or equal to r. However, before we graph down below, we must switch these items around. So I want r over here. I want negative 11 over here. But whenever we switch these around, I also need to switch the sign. So because this sign is currently chomping the r, it needs to continue chomping the r. So our final answer here is r is greater than or equal to negative 11. So then down below, we are going to graph. Quick reminder, how many different numbers do we need on a number line? Hopefully in your head or out loud, you are saying 3. We want negative 11 in the middle. Okay, then remember with negatives, you want to go the opposite direction. So this one right here would be like a negative 10, and this one would be a negative 12. Do not get those mixed up, okay, because you will get counted off. So make sure that you do, in fact, have negative 12 on the left and negative 10 on the right. Then once you are there, you are going to plot the solid dot on number 11, or negative 11, excuse me. And then you are going to shade towards the bigger numbers because r is bigger than negative 11. So my bigger numbers are this direction. Remember, you can also remember that because of this kind of being like an arrow here pointing in that direction. There's example 1. I'm going to speed it up even more on this next one. So again, you have options. This was like 6-5 notes. You can choose to distribute, or you can choose to divide both sides by 3/7. But again, we don't divide both sides. We multiply by their reciprocal. Multiply by 7/3. Reason we do that is because this all cross simplifies. I now have 14 plus h. That whole thing is greater than or equal to on the right side. Cross simplify. So the negative 3 times 7 gives us negative 21. Last step, subtract by 14. I now have h greater than or equal to, when I add those two things together, because they're both negative, it would be negative 35. Box in our answer. And now let's go ahead and graph it. So h is greater than or equal to negative 35. Again, we need 3 points. Negative 35 in the middle because it's negative. I know that this one needs to be negative 36. Negative 34. I am now going to put a solid dot at negative 35, and then I'm going to shade towards this direction because h is greater. Also, you can see that as an arrow. All right, next one, example 3. So again, you have options. You can distribute, you can divide both sides. Because I just divided both sides or multiplied by reciprocal on example 2, I'm going to go ahead and distribute here because I know some of you choose to do that. So I get negative 20. And then I get a positive 4p because a negative 4 and a negative p gives us a positive, and that is less than negative 36. And then to continue solving out, I'm going to add 20 to both sides. I now have 4p is less than, and then when I subtract those two things, really, because they're different signs, you will get negative 16. Divide by both sides by 4. I now have p less than negative 4. Box in our answer. Again, we need 3 points. So our 3 points, we got negative 4, we got a negative 3, and we got a negative 5. This one is going to be an open dot. Okay, open dot. And because p is smaller than negative 4, also you could treat this like an arrow. I'm going to shade towards that direction because p is littler than that negative 4. Okay, this last one is a U-track, so go ahead and pause and solve this one out and graph it, and then check your answer. All right, take a look. Your work should be pretty identical to mine. You needed to show subtracting by 12 on both sides. You needed to show dividing by 3 on both sides. Final answer is y is less than negative 3. Then you needed to have 3 points here down on your graph. And then lastly, it needed to be an open dot shaded to the left because y is smaller than that. If not, go back, fix. All right, let's look at the back. Alrighty, for our real world problems, we're going to do quite a few things. We're going to write, we're going to solve an inequality. You need to define a variable, and then normally you would write a complete sentence, but because these are notes, we're not going to mess with it. So example 5, we're going to do 3 examples together, and then you're going to try one on your own. So example 5, Tyler needs at least $205 for a new video game system. He already has $30, and he plans to earn $7 per hour at his job after school. So how many hours must he work to buy the video game system? Notice that in that question, it does kind of help us out for defining our variable. It says how many hours. So I know that that's going to be what we don't know. So number of hours. Go ahead and do this with me. Always start with defining your variable and then go from there. For example 5, we are going to identify some important info. So Tyler needs at least $205. So that means it's $205, but if I want at least $205, I would need potentially more than that. If you have less than $205, that means that you're not going to be able to afford our video game system. So I'm going to start there for writing our inequality. You got 205, and I know that I want to chomp the other way. You know, could we have $205? Sure. So because of that, go ahead and put that line underneath. But if I want at least 205, think about that. You could have more than that, but we could not have less than that. Otherwise, we couldn't afford that system. Okay, the other important info, he already has $30. So that's how much we have in our pocket is a positive $30. And then the last thing is he wants to earn $7 per hour. We know per stands for multiplication, or $7 per hour. Like if I worked for 3 hours, you would take 7 plus 7 plus 7, but that would be annoying if you worked for like 100 hours. That's excessive. But instead of adding up $7 every single hour, we're going to multiply by the number of hours. So therefore, this is going to be indicated by 7x. So $7 per hour plus the $30 I already have needs to be greater than or equal to 205. So once you write that inequality, go ahead and start solving her out. Because let's get a little extra practice, go ahead and pause the video and work this one out to get an answer. Pause. Alrighty, take a look at my answer. I subtracted 30 both sides. Hopefully you have this work. Then we divided both sides by 7 to get our final answer of x is less than or equal to 25. Now, I do want you to make a little note that in your sentence, we need to use that clue word or that key word to know that this inequality pointed in this direction. So in the sentence, we want to use that exact same wording, or you can use another type of wording if you would like, but you might as well just steal from the word problem. You would need to use the verbiage or the little phrase at least. So in your sentence, you need to use the word at least. So what that would mean is Tyler needs to work at least 25 hours. Don't just say 25, because he could work more than that, still be able to afford that system, but he could not work less than that. All right, let's look at example number 6. Elijah and his sister are going to the movies. They have $34 all together and will spend $9.50 per ticket. How much money may they spend on snacks at the concession stand if they each spend the same amount? Okay, so Elijah and his sister. So I know that's pretty important information. How many people is that? Well, that's 2. Okay, you're going to the movies. Who cares? Yay. Good for them. They have $34 altogether. Okay, and then they will spend $9.50 per ticket. Then the last part says, how much money will they spend on snacks at the concession stand? So that's what I don't know. So go ahead and define our variable. The cost of the snacks. So with the cost of the snacks, I know that I want to spend $34. Could I go over 34? The answer is no, because that's all we have in our pocket. Could you spend $34? Sure, we can spend that. But that means that I'm going to chomp the 34 because that has to be the most that I'm going to spend. Okay, then it's $9.50 per ticket and then some snacks. So I am going to indicate how much just one person has to pay. So Elijah himself has to pay $9.50 for the ticket, plus he wants a snack. But that's just for one human, and I don't have just one human here. I have 2, because I have Elijah and his sister, and they're both buying the exact same thing. So whenever that is the case, go ahead and include how many or how much just one person is getting, so $9.50 plus X. and then tell me how many people are getting that exact same thing. So that's why we needed parentheses in this example. Yes, I know some of you probably are a little bit confused with this per, so $9.50 per ticket, but I already know that I'm getting 2 tickets because it's Elijah and his sister. So that's why it's just $9.50 plus the cost of snacks. And then that whole thing is going to be multiplied by 2 because there's 2 humans. Let's go ahead and pause the video. You can choose whether you distribute or whether you divide both sides by 2, and then you'll get a final answer. Go ahead and pause. Alrighty, did a little of my work. I went ahead and divided here. You could have definitely distributed, but you would have dealt with this decimal. Chances are some of you might have gotten out a calculator, which is a-okay. Just keep in mind that you can only be using a calculator when we do see a decimal. So I'm going to divide both sides by 2. Then I'm going to subtract $9.50. So then you would just take $17 minus $9.50. That's how I quickly did that calculation to find that X is less than or equal to $7.50. And then in your sentence, in the word problem, it doesn't really have like a good phrase or good describing word like example 5 did. So in your sentence, you need to include something that indicates that I couldn't go over $7.50 per snack. So you could say like at most, or you could say no more than. It's just completely up to you. But make sure you don't just say the snacks cost $7.50, because remember, Elijah and his sister could spend a little bit less on the snacks, and then they keep a little bit more money in their pocket. All right, example 7. Molly is going skiing over winter break. The rate is $55 to rent the skis and $10 for each hour. Her dad says they must keep the cost to under $120. How long may she rent the skis for? Important info. First sentence, cool, good for Molly. The rate is $55 to rent the skis. So that's how much just for the skis. And then it's $10 for each hour. Okay, and then lastly, I know that we want to keep the cost under $120. Then in the question, it says, how long may she rent the skis? Also, you could see here, it says for each hour. We don't know how many hours. So that's going to be our variable definition, is number of hours. And then using that information that we just underlined, I know that I want to stay under $120, which means that 120 is the most I can spend. I could spend 119, I could spend 100, I could spend $4, but you can't go over 120, which means that I'm going to chomp the 120, and you are not going to put the or equals symbol because I want to stay under the 120. I couldn't spend 120, I guess. Molly's dad is a little strict. So $10 for each hour. And I know the skis cost $55 to rent. So it does not matter the order because it's a community property. If you'd like to start here and say $55 plus $10 for each hour, I know each is like multiplying. So therefore, this is going to be 10x. Then you're going to pause the video. I want you to go ahead and solve this one out. Push play when you're done. Alrighty, subtract 55 both sides. 10x is less than 65. Divide both sides by 10. Final answer is x is less than 60 or 6.5. So how long may she rent the skis? You would say under 6.5 hours. And lastly, we're going to look at this you-try question. Go ahead and read through this problem and actually just define and set up the inequality. I want to make sure our inequality is correct before we actually solve it out. So go ahead and define a variable, set up the inequality, and then push play to check your inequality setup. All right, here is my variable definition. X is the number of days. Here's my setup, 175 pages plus 12 pages each day. So 12x is greater than 500 because I want to read over 500 pages. All right, and go ahead and pause this. Let's try to solve this one out and then push play once you're done. All right, this one's kind of funky. Subtract 175 both sides. I then divide by 12 both sides, and notice I showed this work off to the side, and I got 27 with a remainder of 1. So because of that remainder of 1, I know that x is greater than 27 point blah, 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 which really in our sentence, we have to use the answer of 28 days. So he would need to read 28 days or greater in order to reach his goal. All right, rewatch, go back, make sure that you understand so the problems become just a little bit easier for us. All right, see you guys.